Peter is one of the people I've learned the most about AI and LLM engineering from here in Vancouver, and I'm so excited. It feels very appropriate for me to have Peter be our first speaker at Infer. So everybody, please give a round of applause for Peter Werry.
Oh, hold on, Jeff, that's fine. So yeah, I'll just give a quick intro of who I am and what we're doing. I'm going to talk a little bit more about the specific problem we're trying to solve, like in the presentation itself. So I'm Peter, and I work for a company called Unblocked. We are solving a very interesting developer problem, which sits at the very top of funnel of the software development lifecycle, which is helping developers get the information they need to get their jobs done. We, as a team, have been together for a little while, probably 7 years or so. We were in Vancouver before as Buddy Build. Does anyone know what Buddy Build is or remember it?
I love Buddy Build.
Awesome. Okay. So we were required by Apple. Ooh, almost said the wrong thing there. Acquired by Apple, and we built Xcode Cloud, and then we left. At Xcode Cloud, I was the head of security and a bunch of internal device projects, and we left and started this company in 22. So that was sort of like predated the explosion of LLMs just by a few months, and then along came OpenAI, and a lot of things changed, everyone knows. So let me just jump right into the problem that we're trying to solve. So fundamentally, we're trying to help this information scattering issue. To understand the problem at a top level when you're trying to solve it, and especially like some sort of software engineering issue, you often need to get context from many different places, not just code. Code is a big problem though, right? Like you need to understand, do a little bit of software archaeology, and normally what this ends up looking like is this. You have to tap someone on the shoulder and you basically interrupt them, or someone taps you on the shoulder and they interrupt you. And these interrupts are pretty expensive. They cost, they're pretty costly, and interestingly, these are some interesting stats. So 53 respondents from a Stack Overflow survey said that they spend hours every day searching for answers, 30 to 120 minutes a day. Okay? And on the other side of things, they're responding to questions. So this is actually a huge problem. It's very costly. Just to now illustrate how we're solving that problem, I'm going to give a quick product demo. I hope this works because the system settings for display was giving me some grief earlier, but we'll see. Okay. Cool. All right, I'm going to just put this up here. So this question here about the source mark engine, the source mark engine is a bespoke component to our system. Essentially what it does is it tracks changes to code through time and through files. So you'll see what it did here. It drew on multiple different data sources to source this response. It's super accurate, so we integrate with all the sort of typical documentation sources you would expect, like Confluence and Notion. It pulled from the source code itself. And then finally, you'll notice down there under references, it even pulled from a Slack conversation. So, you know, it's doing a lot. It's pulling from many different sources. Now, the topic of this talk is about model selection. So, in that context, I just wanted to talk about a few things going on here. The whole inference part of this is obviously like the most complex task. And that's the thing where you take all your context and you ship it off to the model and you ask a question. Everyone knows about that. These things down here, these follow-up questions, that is, it's another sort of text generation task. But what you don't see is all the stuff leading up to this. So this is like the data pipeline type stuff. So now I'm going to switch back to my presentation and hopefully expand on that a little bit. All right, so this slide is meant to overwhelm, but this is just a sampling of the kinds of things that that we're doing in our system. So there's a lot of stuff going on here. I think Alan said, the level of talk, he was hoping for like a senior level talk. I have to apologize, this is maybe like a little bit more high level than that, but these are the topics that I think most people here would be familiar with when it comes to AI tasks, right? And then we have our models. What models can we pick? This is by no means an exhaustive list, and I think, again, everyone that's been involved with this stuff for a while probably recognizes everything here, so I don't need to go into too deep detail about that, except now to talk about how we use models at Unblocked and how we pick them. So the first consideration is like how complex is your reasoning requirement? This is an overriding concern. So you need to pick, if you have sufficiently high tasks for reasoning, like these things here. I put code generation in asterisk, which I can talk about later if anyone's interested, but these tasks really do need the frontier models if you want to get best possible responses. There's no substitute for the highest intelligent model in this respect. No technique can kind of overcome that reasoning bound. And so for those, we use these models exclusively in our system. And I'm going to show a little bit of a comparison between Anthropic and OpenAI at the end. For mid-complexity reasoning tasks, I mixed up the text here. So these are the kinds of things like in the middle of your pipeline where you would do techniques like expand on a query. So by that I mean like in your RAG pipeline, you get a query and you want to expand how many documents you retrieve before you re-rank them. A query could contain some semantic meaning to it, but there might be some adjacent semantic meaning that you're missing in the query that might result in a miss to documents. So one example to this is something that is sometimes solved with multi-hop retrieval. So imagine like someone comes in and they say, show me how the implementation, or show me how the implementation works for this API path. Okay, so they supply a path only. Now what's going to happen there is you'll probably get a hit on a document like an open API YAML file, for example. But you may not get a hit on the actual implementation for that file. So query expansion or query optimization can help with this problem because you can basically like reframe the query so that you add contextual information or you reshape it in a way that allows semantic retrieval to expand. And then after that, you can use a re-ranker to figure out how it best aligns with the actual query. Okay, so for large volume tasks, these are typically the things that happen in the data pipeline, right? Things like summarization, classification, filtering. This is like when you're chunking up your data, you may need to annotate it with some additional information. Or you might be trying to build a graph reg system, which is really heavy on summarization because it progressively summarizes as it walks up the graph, okay? For these types of things, if you're doing it at scale, it's just way too expensive to use any proprietary models. So for these things, we have no choice. We have to use open source models that we host. At least that is the case today. In the future, that might change. But today, it's just too expensive to use even the lowest fidelity models in the proprietary model set. Just on embedding specific, yeah?
Is it just the expense, or would latency and throughput also be an issue there?
That's definitely problems. You're right. So like rate limiting, for example, is one of the biggest issues because if you're doing it at scale, you're going to get rate limited. There's no question. But I think that rate limiting is the higher order bit compared to latency.
Yeah.
Just to give a sense on embedding specifically, so these rankings change constantly. I just wanted to make a small mention about how these rankings are shifting. I think people are like building against the benchmarks. So what tends to happen is it looks like it's doing really, really well, especially like the NVIDIA embedded model. It looks like it's like just baller. It's killing all the competition, right? But you can't tell for sure until you actually run the experiments yourself, because embeddings, it matters what type of content you're embedding. Like if you're embedding code content and you want to combine that with textual content, you might find that Mistral does a better job than all these. If it's just long form content, you might find that NV Embed does the best job. And there are code-specific embedders that do very, very well on code-specific tasks. For re-ranking, we use Cohere. And I've got a few reasons for that. Firstly, like re-ranking is quite a big topic. And lots of people use different techniques like reciprocal rank fusion, which are kind of like procedural. And then other people use crossing quarters, which I believe is what Cohere is using with their re-rank model. The reason why we use Cohere, one, it's really, really cheap, amazingly cheap. It's actually cheaper than if we were to host the model ourselves. Second is they're Canadian, so that's pretty cool. And then the third is that this is the core of their business. So they are laser focused on making this thing better. And they, like a lot of SaaS companies that are early and scrappy, they work super hard with customers in order to tailor their solutions to their needs. So just a food for thought. If you're looking for a reason to go with a SaaS model, those are some of the big ones. The last thing I wanted to point out is, what if you need big context? Okay. Unfortunately, there's been a lot of efforts to try to expand context windows, but all have failed in one particular respect, which is needle in a haystack. So if you have huge context, the attention just drifts everywhere, except for Gemini. Now, the problem with Gemini is that while it's able to pay attention to things, its reasoning capabilities just aren't there for like the main reasoning tasks. But there's a really interesting use case for this, for the big context stuff. So there are some questions that we get from customers like, what does my repo do? That's a really high level question, right? Now, if someone, think about what that means like in terms of the actual implementation. Like, you would have to have this kind of really high level holistic understanding. So behind the scenes, one possible technique you could do is just summarize a bunch of stuff and like progressively work that up. And that ends up being GraphRank, for example. And GraphRank is actually pretty good at that. But it's super expensive. And there's loads of other techniques like connecting the dots on code, using AST, code annotations, call graph analysis, all sorts of stuff. But, and this is what we're experimenting with right now, it might be possible to take like a large part of that code and just throw it at Gemini and get it to reason about like all the places this is used. This is my favorite question. Find all my dead code. It's so funny. It's like find my dead code or find my hot code. And we just can't solve the problem right now unless you have like massive context to deal with it. So anyways, that's just an interesting observation. Okay, so now on to the interesting model comparisons. This is sector. For some reason my notes aren't showing up. There we go. So in this one here, I asked, can you guys read that? It's probably super small, right? Yeah, I might just have to speak to it. In this example, I asked the models to generate some tests for a class. And what you'll notice here is that OpenAI's response is super verbose. Like, it really goes to town. We found this to be like a general trend with OpenAI, that it gets very wordy, even when you instruct it not to. Like, be more concise, please. Like, cut it down. My child is going to die tomorrow if you don't. And it just won't do it. So verbosity, Anthropic tends to win. Now, attention is super interesting, okay? Anthropic seems to attend more to technical stuff, like code or technical documentation, README files, etc. This was the exact same prompt. I asked it how we preserve context and key entities from previous messages in the chat. So this thing was talking about the so-called query compressor. And Anthropic zeroed in on the technical implementation. You'll see that it basically just talks about the query compression step. But OpenAI took a more holistic view of the content, pulling from a variety of different data sources to draw like a wider picture. So that's just an interesting observation. So not necessarily a bad thing. There are cases, for example, where you want the thing to pay attention closer to the technical stuff. And what's really interesting about Anthropic is that it actually did way better on this question. The reason for this is I asked it, how do I add new pinecone metadata field? And you'll notice that OpenAI's answer basically like zeroed in on this Python file. And we think it's because it's been tuned to attend more to Python related content, but also because the stuff in that file is like, it's very direct. That Anthropic basically discarded that and chose to look at the surrounding context that we provided it. So it understood that it had to focus on Kotlin because Kotlin was like all the rest of the surrounding context. The Python file was like one file. The Kotlin files were many. There was like 10 or 20 of them. And it understood that was the core focus and kind of blanked everything else out. So that is to say that we use Anthropic for super highly technical questions and questions that are asked from the IDE. So I forgot to mention, we have multiple clients. You guys saw the web client, but we also have a plugin for Visual Studio Code and IntelliJ. And when you ask questions from there, it understands a little bit more. It understands what you're looking at, kind of what your surrounding context is, and it knows that you're probably trying to ask a very technical code-related question. And if you're not, it'll help in that way, and it'll switch back to use OpenAI. But in most cases, it will do this. Okay, so to summarize, OpenAI, it's actually better at logical reasoning and code understanding Anthropic. Better than OpenAI at code understanding and logical reasoning. Leans super technical in its output. One interesting thing is we find it tends not to follow formatting instructions too well. So it always regresses to lists. List. And it's not super great at markdown, so that's another thing. And then finally, this is an old observation, but it remains true today, even with the frontier models, which is the context in the middle issue. Everyone knows what I'm talking about there. You've got a really, really long prompt. The model essentially completely loses focus of everything in the middle. So it knows what you gave it at the top, it knows what you gave it at the bottom, totally ignores the middle. So that's still a problem today. And finally, OpenAI. All the good things. It tends to be just, because it's so generalist in its reasoning, it's super good for those wide questions, and to give you a sense of a use case, we have a lot of customers that have support channels. And people come in that are not necessarily super hooked into the technical aspects of that particular team's day-to-day things. And so they tend to ask higher level questions, and they prefer higher level answers. And in those cases, OpenAI is generally better because it pays attention to the surrounding context a lot more. But if you're in a situation where you've got a team that's been working together for a while, and they're just really hyper interested in the super technical details of things, Anthropic tends to do a better job today. Not to say that that's not going to change, because it probably will. Yeah.
Since we're on the topic of comparing models to make the right choice, right? How do you kind of benchmark this comparison? The reason why I ask is, a lot of times you have to rely on fallback models. Like you said, rate limiting hits you every time.
Yeah.
And especially in our case, because we use Llama self-hosted as well. If your spot instance dies, you're screwed.
That's right.
So, but the moment you fall back to another model, even if it's a similar parameter, even if it's Llama 3 but just by a different provider, because they definitely have fine-tuned it a little bit, your output just goes for a toss. So the same prompts start misbehaving.
Yeah.
So how do you benchmark similar answering models so that you can use them as fallbacks for each other or substitutes for each other?
Yeah, that's a good question. It's like, yeah, because we used to have OpenAI and fallback to Anthropic.
Oh shit.
Yeah, we actually stopped doing that because the answers were so different. Now what we do is we round robin Azure's OpenAI stack. So yeah, I mean that we have customers that prefer that anyways. They're like Azure specific. So, but yeah, how to benchmark that stuff though? It's super hard. Alan's going to talk a little bit about the eval stuff, but at a high level, we have a feedback mechanism where we're able to run automatic evals on the content that's flowing across, and so like, we get signals on when things are going wrong, but that's not the same thing as like, how are things getting better or worse over time?
Right.
Yeah.
Two questions. One, 4.0, how about 0.1 in comparison?
Oh yes, okay, so the question was how about 0.1? Okay, so 0.1, we don't use it for the simple reason that it doesn't have streaming support. The other problem is the latency is just way too high. So if you set user expectations properly, then for sure, like 0.1 provides a much better outcome for its reasoning capabilities. What we find is that while it still doesn't support system prompts, we think the reason for that is because it's doing all that itself, back and forth, back and forth. And so when we supply it with our instructions for behavior and formatting and reasoning and stuff like that, it takes it all as like the user is asking a question, and so we lose a lot right now. They'll probably do better on this, but so it makes prompt breakouts possible again. It makes it just doesn't follow the instructions that we give it very well, and it does zero in on task and try its best, but yeah, you lose a lot right now.
Right. And the second question, you're doing a ton of work on the way into these models. What about on the way back out? Are you post-processing, refiltering, reformatting their answers?
Yeah, for sure. Yeah, definitely. Like it sometimes does weird formatting things with URLs that it spits out, for example. We use a technique for references where we call it impromptu reference tracking. By the way, Sonnet or Anthropic used to be really bad at this, but Sonnet 3.5 is now on par with Omni. So the way this works is we ask the model to kind of keep track of what it's using in its response. That sounds like a pretty tall order, but through various different prompt techniques, you can actually, what it translates to is attention, right? So you get it to basically like front load the attention that it's using as it generates token after token after token. And so the attention that has like the highest weights is therefore used to kind of spit out the references at the bottom. And we do that by just getting it to spit out reference IDs from the original document source in the prompt. We provide IDs. And then, to your question, the IDs come out and we have to post-process to swap it with the actual data. If you don't do that, it overwhelms the model. It just is dealing with too much. So sometimes you have to take your data and like cut it down and simplify it, and then like fill in the gaps after. Does that make sense? Yeah.
Not exactly a model, kind of model selection, but just expanding on the example you just said, right? That you're giving a big context to the model and you're saying that keep track of the references you're using so that you can use it and show it to the user essentially. So one way is to make it in one query and put in instructions like you just did. You probably need a bigger parameter count for it.
Yeah.
Another potential way could be like use smaller models, but have the first model just identify the important references.
Yes.
And have the other fill it in.
Yes.
Have you had these multiple step small model versus
Yes.
one big step
Yeah.
big model?
Yeah.
Have you done that before?
For sure, yeah. Actually, we did it that way. We also did it the other way. So we like spit out the response first and then generate the references off the back of it. But I mean, either way, we just found it's so interesting. If you do it the other way, where the response gets spit out first, then you have to pass not only the response but also the original document set if you do post processing on it. It's kind of like an eval in that sense. What we found is the model like just picks everything. It's really odd. Like, and this happens with both Anthropic and OpenAI. If you do this kind of like post-processing thing, the model like kind of leans towards, thinking that everything should be a reference. And that's probably because, well, maybe our eval's crappy, I don't know, but like it just goes all over the place. On the front end, it does the same thing too. It's like, yeah, these are great references. This will generate a great response, and then it doesn't match up to the actual answer. Yeah.
Are you, or this is for Patrick, are you done with slides?
Oh yes, done with slides, yeah.
Yeah, okay, cool.
Yeah.
Thank you, that moves the field from my question.
Yeah, so we have a few minutes for Q&A, so just hands up and we can pick.
Yeah.
So when you're dealing with multiple models and evaluating them for different purposes and different parts of the pipeline, how do you think about these trade-offs in the context of like prompt tuning? Because like you could like asymptotically invest in any particular prompt against a single model, but then it obviously like branches when you are considering multiple models. So how do you guys approach that?
Yeah, it's a super hard problem actually.
Can you repeat the question?
Yeah, so the question was like, how do you balance the, and correct me if I don't get this right, but how do you balance the decision-making process in selecting models with the need to constantly evolve different prompts for different models, because it is pretty painful, and are there sort of like any techniques to make that less painful? So yeah, I mean, we still have this problem today. Like we have specific prompts directed to Llama, specific prompts for Anthropic, specific prompts for OpenAI. Now we actually built a intermediary like language to try to transform those prompts, but you end up like it's not enough just to transform the structure. There's like specific things that you need to change about instructions and so on. There was a really interesting project that I ran into at a recent conference in Denver, where this guy had created an AI-driven prompt optimizer.
Yeah.
So it is a technique that's interesting, and I think what's that library that everyone uses for this stuff now?
DS5.
Yeah, DESPI. Yes, thank you. And it's an interesting approach, but we found that it doesn't quite get it right because you need a lot of sample data in order to evaluate whether it's doing the right thing. So maybe that's just that's probably on us. Like we could take a load of sample data, throw it at that thing, use DISP to optimize the prompts, and maybe that's the way to go. I don't know. Yeah. Yep.
Are there any specific evaluation libraries that you found useful?
Eval libraries?
Yeah.
We've tried a few. The issue that we run into with evals is it's highly dependent on the thing you're trying to evaluate. And so the prompt always ends up being micro-tailored to fit the needs of that evaluation. And I think Alan will probably talk more about that. Yeah.
In that case, do you absorb customer feedback?
Oh, definitely, yeah. So I'm not sure if you noticed this. I wish I could go back to it if you want, but at the bottom of the Q&A, there's like a wrong, okay, or good feedback button, and then if you select wrong, you put exclamations, and you actually read all of those responses. There is automation that's happening here too, because I know that's going to be the next question. At least to evaluate what went wrong, or what could be done in the future to make it better. But yeah, that AI is still not that great at that. You can't really ask it how to fix things. It's just not smart enough.
All right, got time for 2 more questions if there are.
Yeah.
We talked about large language models, but I want to get your opinion on evaluating embeddings, how you go about figuring out what the best kind of chunking strategy is, pre-processing for embeddings to get that output that we want.
Just loads and loads of tests. Yeah, like you have to run it through the entire pipeline. That's the thing that's a bit of a drag. You can benchmark retrieval, so you can have like a golden set of retrieval documents, you can't really compare scores because vector scores are different for every embedding model, but you can compare order. So like n documents. So you have the golden set of what you expect to come back for a particular question, and then you can just drive like whack loads of testing on that. We actually synthesize questions for this purpose. And then, unfortunately, we had to have human in the loop to determine what was the best thing, and then drive a bunch of tests against it. Yeah.
And for one more? There's
Yeah.
So to get the customer data, do you have different scraping processes, or how do you go about that?
To get customer data. Each of those integrations is, it's an OAuth connected integration, and so we hit the API and ingest the content that way.
awesome. Well,
Sweet.
thanks for your.
Yeah.